qualitative sort of examples of the Bernoulli equation. So let's imagine, for example, that you've got structure like that, like the wing of an airplane. As the wind blows over it, what happens is it takes a longer path over the top than the bottom. That means makes it go a little bit faster over the top than over the bottom. So what happens is the difference in height is negligible right here. So the air pressure is different, is not much different right here, and so you would expect normally, but P1 plus 1/2 rho V1 squared plus rho G Y1 equals P2 plus 1/2 rho V2 squared plus rho G Y2. Density of air is very, very small, so these two terms are very small and they don't matter as much. So if we call that 1 and that 2, then what happens is if this is bigger, that has to be smaller. If this is smaller, that has to be bigger, and you end up with more pressure up than you do down. And so that actually is part of what provides lift for an aircraft. Now, that's not the only thing that provides lift. That actually turns out that typically what happens is the wings are also, what happens is the air hitting it gets deflected down, and that chain provides some lift also. So you actually have a combination of things that happen here. You actually have both factors working on an aircraft in order to provide lift. But in a sailboat, for example, if you get a small sailboat here, then you got a mast and you got a sail, and I had a friend that had a sailboat once, and I went sailing with her a couple of times. It was kind of interesting because it was like we weren't going in the direction the wind was blowing. And so what was happening? Well, the wind could actually be blowing at an angle like this. And what would happen is it would cause the sail to balloon out like that because the area of the sail was actually larger than the area of the mast plus the boom. And so as air went by, it would take a different path across the front than the back, and that would provide a force like that. The keel of the boat would provide a force this way, and what was left was a component like that. Now, there's another sail that you could have put out here, that was held by sheets here, or ropes. Technical term is sheet. And so instead of on the mast, that's called the jib. And what happened is it would cause air between the two to be funneled through here and go even faster. And so that would provide even more force right there. And so so that's basically how a sailboat works. And so that's how you can actually sail into the wind. Okay. Another example here is in biology. You have an artery. So we imagine that we have an artery right here. Okay, and so what happens is that the pressure right here in your body pumping blood, well, your body is all full of fluid, so you have some like resting pressure in your body up here. Now, what happens is if you start eating the wrong kind of foods, you start developing plaque and fatty deposits in your arteries. And so what happens is the velocity increases right there. Okay, well, if the velocity increases, the pressure there decreases. If that pressure becomes less than the pressure on the outside, it actually squeezes off the artery, and this is one way you get a heart attack. The other thing that can happen is that you could have a bulge in your artery. That's called an aneurysm. Now, in that case, the blood velocity slows down right there. If the blood velocity slows down, that increases the pressure pushing outwards on your aneurysm, and it can balloon out even more until it ruptures. Okay, so aortic aneurysm, an aneurysm of the aorta is typically fatal if it ruptures even if you're in the hospital, if it ruptures, unless you have to be on the operating table and they're already doing surgery, you're not likely to survive. Uh, um, an aneurysm rupturing in your brain, that can give you a stroke. That's another example here. There was another example over in Dallas a number of years ago, and that was they had been doing a lot of construction, and so you have the street here. You had a manhole cover. This is a sewer, underground sewer down here, and you had some kids playing in the street. It was kind of like a neighborhood where the kids were all playing in the street, and it started raining, and so they had blocked up the drainage here, and so water was standing in the street here, and the kids were playing in the water in the street, and then water started gushing down here. Well, air is not incompressible. So as this wall of water started gushing down the sewer, it compressed the air, increased the air pressure, which blew the manhole cover off. Then the flood of water went going by at high velocity. That decreased the pressure and created suction, which pulled all this water down here, including two of the kids. And they found them like a couple of days later way down the Trinity River, and at least, their bodies. And so that was not a good thing, but it was an example of Bernoulli forces at work. You can see this lots of different ways. Other places you see Bernoulli forces is if you've got a tarp over the back of a truck or something, then the air is not flowing underneath the tarp, but it is flowing over the tarp. So as the truck's driving along, the tarp is ballooning upwards. And so that's another example of Bernoulli forces at work. So there's lots of places where you have examples of the Bernoulli force here and applications thereof.